So on that exponent review page that I hand wrote, and we're going to look at a couple of the other pages later. Right now we're on that one. So we are this is not good on my part. Number 1 and number 5 should say solve, not simplified. So these are not simplified problems. This is a solve problem. So we're going to do 1 and 5 first. This one, number 1. All right, so who had a thought on this? Some of you did this problem. Charlie?
Well, I remember from last year, what we did was we'd find like a common thing that you could exponent by.
Common base, yep.
A common base.
Yep.
So these both look like a 3 to me. So that's what I put as the base. And then 27, you just multiply those exponents by 3. It's 3
So
to the
27 is 3 cubed.
Exactly.
And then when you have a power to another power, you multiply. So this is 3 to the 9x minus 3 power. Perfect. And then over here, same thing, only you use 3 squared. So that's 3 to the
10x plus 8.
Is that okay with everybody? Now, this is an equation. We're not multiplying these or adding them or doing anything like that. These are equal to each other. And if 3 to this power is the same as 3 to this power, then doesn't it make sense that the powers have to be the same? That's why you got a common base, so that you could draw them out, basically. So that looks like x equals negative 11. Did everybody who did that, got that? Now this one, I don't know if I wrote it wrong or what. Did anybody have an idea on this one? I think, I have no idea. I am going to erase that x and just make it this. I think that's what I meant it to be. Otherwise, we're going to need a calculator to do this problem. So I think I just wrote it wrong. So now, is it the same kind of problem? So what shall I use as my common base? 2. So 2 cubed and 2 to the 4th. So this exponent is 9x minus 3. And this one is x. So I am getting 3/8 as my answer. Everybody, sorry about that typo. Spent too much time on that. Now the rest of them are simplified. So the rest of them will not be x equals. The rest of them will just be simplified versions of the original problem. All right, so tell me what you did with number 2. Lily, did you have a thought on number 2?
Well, I didn't know which was wrong. But we put 16 1 over 16 and take the 4 root of it.
Okay, so let's just look at one piece of the problem at a time. Lily says I'm going to figure out what this equals, and I'm going to do it without my calculator. So when I have a negative exponent, I know that I reverse my base. So instead of 16 over 1, it becomes 1 over 16. That's important. You have to know how to deal with negative exponents. And then a fractional exponent means a radical, and it's going to be some root of 1/16. The denominator tells you which root, and the numerator tells you what power to raise it to. So this is the fourth root of 1/16 cubed. Well, the fourth root of 1/16 is 1/2, and 1/2 cubed is 1/8. So this thing right here just equals 1/8. Now I'm going to multiply that times this. Well, that's easy. That is 1 over 36. I'm just going to multiply those numbers. And I don't know what that is. 1 over, is it 288?
Yeah.
So the answer to the problem is 1 over 288.
Couldn't you do like 2 to the 4th for the first part of it? I did 2 to the 4th, and then you multiply by negative 3/4.
Absolutely.
Okay.
And you get 2 to the negative third,
Yeah.
which is 1/8.
Okay.
Okay, everybody okay on that one? All right, number 3, we actually did some of these earlier in the year, I think. Did anybody have any idea what to do here? Sam?
I like to deal with the negative. I flip like the numerator and denominator.
So Sam chose to start the problem by taking care of that. So he says that flips the entire fraction. Nothing changes. The top comes down, the bottom goes up. But now his power is to the second. All right? Now, you don't have to do things the order Sam's doing it. That is correct, right? He's okay. It's all right. All right, now what did you do, Sam?
I distributed the exponent.
So you took everything to the second power, including the 3 and the 5. So you got 9x to the, remember, this is a multiplication, power to power. So x to the 18, y to the 16, 25, x to the negative 4, y to the 12. Does that look okay, Sam? All right. And then what did you do?
Like I simplified the everything. I guess I moved the x. So I added the 4 to the 18. So I got x 22, x to the 22nd.
Exactly.
And then subtract 12 and get y to or x y to the 4th.
Perfect. Beautiful.
Should y to does y to the 4th go on the top?
Oh, yeah, it does. Thank you. It does, Sam, thank you. Because 16 is bigger than 12. That's fine. It's beautiful. And you may have done things in a different order. I know I would have, but the answer better be the same. Everybody good on that one? All right, number 4. Anybody have an idea? Number 4, it looks kind of like the one I'm just erasing. If you wanted to, could you bring that 27 to the 2/3 to the bottom? And take the 1/4 squared to the top if you wanted to. I'm not saying you have to, but if you wanted to, could you do that? And make 6 squared up here. So now I don't have any negative exponents. Let's simplify each piece. What's 1/4 squared? What's 1/4 squared? It's just 1/16. And 6 squared is 36. And 27 to the 2/3 is the cube root of 27 squared. So 9? Everybody okay with that? Just kind of doing the arithmetic for each piece. 36 over 9 is 4. And 1/16 times 4 is 1/4. So again, you may not have done things in exactly that order, but doing whatever it is you're doing, let's end up with 1/4. Okay? Alright, we did 5, 6. Now, once we did like the Sammy one night just a little bit ago, and we went through in the order that Sam suggested, everything worked out great. Personally, when I have something like this, I like to clean my inside up first. If there are X's and Y's, I'm gonna clean them all up. Now, Sam can do whatever Sam does, and you can do whatever you do, and it's okay. I'm going to clean this up. So what I'm going to end up with is, I'm going to subtract these exponents. It's a division. So I'm going to get x to the negative 2/3. Does that, you may not do it this way, but does that make sense to you? And then I'm going to subtract these exponents. So 7/8 minus negative 3 is going to get me 31/8. And I'm going to raise that to the negative 1/2 power. So I'm going to have x to the 1/3 and y to the negative 31/16. Everybody still with me? I'm not supposed to have negative exponents, so that's x to the 1/3 over y to the 31/16. That's not good either, because isn't this a radical? Right? I don't really want to have a radical out here. So I'm going to multiply by something so that this will be a whole number. And remember, you're going to add these. I'm going to add these exponents. So what do I need to add to 31/16 to get a whole number? Oh, so it's 1/16. Because then my denominator will be y squared. And my numerator is what it is. So again, the order that you do all this stuff, there's no set order. You can do whatever you want. But let's make sure we're ending up at the same place. Question about that? All right, here we go. This is not an equation, so you are not going to end up with x equals. You are going to simplify this, and instead of having 3 things, you're going to have just 1. You're going to put it all together. So Leo, you all right? what do you notice about all of these numbers? The powers of 5. So let's rewrite 25 as 5 squared. And 1/5 will be what? 5 to the negative first. And 125 is 5. Alright, so we've got 5 to the 2x minus 8 times 5 to the negative 3x minus 2 over 5 to the 3x minus 9. So far, so good? Now, what can I do with these exponents right here? Add them. So I have 5 to the negative x minus 10 over 5 to the 3x minus 9. What can I do with these exponents? Subtract. So I have 5 now to the negative x minus 10 minus 3x plus 9 power. I'm subtracting. So my answer is 5 to the negative 4x minus 10. Okay? So the key to doing that problem was making all those bases the same so that you could combine the exponents. And it was 1, 5 instead of 3. Alright, last one. If you've already done it, great. If you haven't already done it, do it right now in your own style. And let's see if we all match. Somebody want to come up and do it on the board? Well, thank you, Celeste. And everybody else, if you have already done it, great, you can just sit there. Or check your work. If you haven't done it, let's do it. What do you think? Anybody have a question about that? Nicely done, Celeste. Thank you very much. All right, let's put that guy away. And now, get out the one that says worksheet topic 2.4, kind of cut and paste it together. You got this one yesterday too. And in a minute, we're gonna work on this with our partner, but I want to fill in those charts up at the top first. So we're on this sheet, and we're just gonna rattle off, we're gonna fill in that first chart. So what is the exponent form of that first problem? 2 to the fifth. 3 to the sixth. 4 to the eighth. X to the sixth. And X to the A plus B. Very, very good. All right. Next chart. 2 to the sixth. 4 to the 15th, X to the 12th, 6 to the 3rd, good, 6 to the 3rd, 12 to the 3rd, X to the 3rd, Y to the 3rd, X to the 3rd, Y to the 3rd, and then X to the AB, and X to the B, Y to the B. All right, last one, last chart. 3 to the 3rd, 2 to the 3rd, 5 to the 4th, 4 to the 2nd. We can't move on this paper. You have this paper. So did you do 4 to the 2nd?
Yes.
And then X to the 2nd, and X to the A minus B. All right, there are 9 little problems down there at the bottom, they won't take you long to do. But I'm going to have you do them, and then I want your answers on the board. We'll talk about anything we miss. So we'll do 1, 2, 3. So one person can come up and do 1, 2, and 3. Somebody can do 4, 5, and 6, and 7, 8. So you can talk about them, work together, whatever.
I knew that they're
Find it. Yeah, this is the one we did first. Okay.
wait. Isn't it into the 6? Not 8. But 3, I distributed it. What do you do with So,
Now you're
two
doing
X,
these right here.
That's right.
2 Y.
Oh, no, I What'd you get lighter? Wait, where'd it go? No, it's 2, X, Y.
No. I think it's this. I think it's
Right?
I mean, it's
first three. Everybody should have the first three done. How do you feel about those answers?
Oh. So it's not friends.
Guys, are we okay with the first three? Everybody good? No questions about the first three? Perfect. We'll give you a couple more minutes and we'll check on the second three. Sam, the last one.
The last three.
Yeah.
Sure.
For 9, you combine.
All right, let's look at the middle of group 4, 5, and 6. What do you think about 4, 5, and 6? With number 6, I went ahead and made that 64. I think that might be a good idea. If it had been 2 to the 100, I probably wouldn't have done that, but I think that's okay. And then Sam finished it up for us. I like all those too. I think we got a perfect paper. Anybody have any question about those? You okay? All right, let's turn it over. I think we talked about this before, but just to make sure, we know that anything to the 0 power is 1, right? And that is because if we have x to the 7 over x to the 7, we intuitively know that's 1. They cancel each other out. But if you use your properties of exponents, it's x to the 0. So x to the 0 must be the same as 1. Unless x is 0. Because obviously, if x is 0, we have a problem, don't we? So 0 to the 0 is undefined because it came from this, which is undefined. Everything else to the 0 power is 1. Right? Alright, so let's look at part 1 then. We're going to look at 1. Let's simplify these real quick. What's 7 to the negative 2nd? We don't need a calculator for that, Alberto. I don't know what you're doing. 7 to the negative 2nd is 149. 2 to the negative 1st is 1/2. 1 1/3 to the negative first is 3. X to the negative third, 1 over x cubed. And 2 plus 4x to the negative second would be 1 over 2 plus 4x squared, wouldn't it? You don't distribute the exponent, that's a FOIL problem. If you're gonna do anything with that, it's gonna be a FOIL. Right? Alright, part 2. 8 to the 2/3. Now, I don't care how smart you are, your brain does not process that. When you see 8 to the 2/3, you immediately think cube root of 8 squared, which is 4. And then the next one, the 4/3 of 16 is 2. The square root of 4 cubed 8. And then 1 over the square root of 100, which is 10 cubed, 1,000. So 1 over 1,000 for that last one. Alright, let's have you work with your partner to simplify part 3. Now, part 3 stipulates no negative exponents, but you may leave fractional exponents in the denominator. So no negatives at all, but you can leave fractional exponents in the denominator for these 3 problems. So let's go ahead.
So it goes down to 110.
These.
So it goes to 110.
Yeah.
And we'll have one group put up 1 and 2, and one group put up 3 and 4, and one group put up 5 and 6.
Well, when you use Wait. Well, yeah.
Which part? 7 plus 1
I think that's yeah. Yeah, like
It's okay to have it. Like I said, it's okay to have fractions. It's totally not.
Yeah, 2 will actually cancel out. So that's
So just to clarify, problem number 1 would be this. Would everybody agree with that? And I said you can leave the fractional exponents in the denominator. If you wanted to remove them, you would have to multiply a to the 1/2, b to the 1/2, and that answer would be a to the 1/2, b to the 1/2 over ab. But I told you you didn't need to do that. We're gonna go ahead and leave our fractional exponents in the denominator.
Yeah, but,
Is it an emergency?
no.
Okay. If it's an emergency, I want you to go, but we have 15 more minutes. for number 2, I'll go ahead and do that one. I hope you got 1. Because anything in 0 power is 1 except 0. So there you go. All right, I got those done. I'm waiting for 3 and 4 and 5 and 6. Somebody to do those. I have 5 and 6.
Look, I would like number 5. Trick is nice, except I don't like the fact that,
Here's number 3, that's what I got, that's right. And then number 4, you could have stopped here. Whoever did this went ahead and rationalized correctly. So this would be the completely simplified answer. And by simplified, it means no radicals in the denominator. So I told you to stop here, that is perfectly okay to do that. Anybody get an answer for 5? We're gonna do 6 together. I hear a lot of conversation about it. But what about 5? You probably got 5, okay? What did you get for 5? I did a 1/3 over x to the 4/9. That's what I got too. Now that isn't rationalized, but I told you to read it that way. If you were gonna rationalize it, you would multiply by x to the 5/9, right? So your denominator would be just plain x. All right, let's look at this one. There's a lot going on. This is not a hard problem, it's got fractions in it, but there's just a lot. So you wanna get organized, decide what your strategy is, and then get organized. So, again, I like to clean up the inside. Not everybody likes to do that, but I like to clean up the inside. So I'm gonna go ahead and do that. So I have these two y's. I can actually add together if I remember. So I'm gonna end up with y to the negative 5/3 on the top. And then on the bottom, I gotta do this. So that's gonna be x to the negative 5/2 when I multiply those. Yeah. And y to the negative 9/2 when I multiply those. I haven't done that yet, that's still out there. I combine these two, I distributed that exponent right there. Now I'm gonna combine these. So this is gonna be negative 5/3 minus negative 9/2. So I get a common denominator. And it looks like 17/6. Check my math. So y to the 17/6 over x to the negative 5/2, or y to the 17/6 times x to the 5/2. How does that look to everybody for the insides? To the 3/2. This is not what I got the first time I did it. So I got x to the 15/4, I think that's what I got, but now I have y to the, why that reduces, yeah, that's what I got, 17/4, that reduces. That's what I got when I did it before. Wrong way up.
I was confused about the numerator, just the common denominators for
And you didn't have to combine those, I just did it because I'm trying to do that. Sam?
Are what number is the denominator of the exponent?
X to the negative 5/2.
Like in the answer, I just.
No denominator, it's gone.
No, the bottom part of the exponent.
Here?
Of the final answer.
Oh, 4, for the 4s.
Oh, okay, that's it.
All right, quickly, get your notes back out. And on the back of page 11, let's get some questions answered if you can. On the back of page 11. In our notes, the back of page 11. So we have a function. Two to the x plus 1 plus 6. What is the parent function of this? In other words, what is your baseline function? Y equals 2 to the x. And then what have we done to it? We've taken y equals 2 to the x, which is our regular old exponential, and we've done what? 1 unit to the left and 6 up. Now remember what your basic exponential looks like. Your basic exponential, regardless of base, goes through the point 0, 1. 2 to the 0, 1. That's your y-intercept. You've taken this picture and shifted it 1 unit to the left and 6 units up. What is the domain of that function, after we have shifted it 1 unit to the left, what's its domain? Still all real numbers, isn't it? Negative infinity to infinity. But what's its range? Originally, the range was 0 to infinity. Now the range is 6 to infinity, because that asymptote is now up at 6. What is the y-intercept of function g? Well, don't make it hard. You can just plug in 0, right? So what is the y-intercept of function g? 8. Sketch the graph of g and find the end behavior units. So, sketch the graph of this thing. My asymptote is going to be up here at 6. Intercept is 8. Same picture, right? Just moved over 1, 6. Oh, so what are my end behavior asymptotes? What's the limit, or my end behavior, what's the limit as x approaches negative infinity? 6 from the top. And what's the limit as x approaches positive infinity? Positive infinity? Charlie?
But why is the y-intercept 8 if like, it's like, the regular one is like at 1? Why is
Remember,
it?
we moved it 1 to the right, or left, I mean. So that point in the new picture has been moved left 1. So this point right here is negative 1, 7. And then you have to go over another one. It would be 7 if we had shifted it left, but we shifted it left. All right, an exponential function of 4 is shown. Which of the following statements is not guaranteed? All right, well, that one's gonna take a little bit of thought, so we'll stop there. Tomorrow, you have a homework due, and we're gonna have an exponent quiz, all right? So we did all exponent practice today, that's all we did. So tomorrow, we're gonna have a quiz over simplifying exponents. So basically, it's gonna look like that worksheet that we did first and second, the 2 papers we did first and second. Those kinds of problems. All right, just a quiz. 4 or 5 problems. Got it? So, if you struggled with anything today, you can come to office hours tomorrow. Or you can practice some more of those things on your own. Review those sheets.